Welcome, 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 everyone. Thank you so much for coming to our session. This is SEC340, IAM Access Analyzer Deep Dive from Configuration to Remediation. Quick question before I get started. How many of you, is this your first session of the conference? Can I see some hands? Yes. Thank you. Thank you for making ours the first. And for those of you who, already attended something else, that's great too. Thank you for going and supporting whoever that was. My name is Jeremiah Dunham. I am a senior software development manager here at AWS. I am on stage in front of you talking about IAM Access Analyzer because I lead the IAM Access Analyzer engineering team. So my team builds this product.
And my name is Mitch Beaumont. I'm a solutions architect based in Sydney, Australia, and I get to work with customers on a daily basis, helping them figure out how to assemble the AWS building blocks like IAM Access Analyzer. And hopefully I can bring some of that here today and share with you to take home to your own organizations.
Yeah, oh, sorry, geez, I got a little button happy there. Between Mitch and I, as I'm sure you gathered, right? So I understand what's going on behind the scenes with IAM Access Analyzer, build the product. Mitch works with customers who use it. So between the two of us, we should be able to cover pretty much anything you want to know about it. This is a code talk, so we're going to get into some code and some demos and things like that for you. But first, we want to level set. So you're going to have to listen to me talk for a few minutes. And for that part, here is the agenda. I'm going to talk a little bit about journey to least privilege, give you an overview of IAM Access Analyzer. I'm going to talk about this much about automated reasoning, and if you don't know what that is, that's okay. Hopefully you'll know by the time I'm done. And then I'll turn it over to Mitch. And let's code, kinda. In fact, before the session, I was joking with Mitch that now that we have Kiro, who writes code anymore anyway? You just tell the agent, it goes and does it for you. All right, so IAM Access Analyzer. The goal of IAM Access Analyzer as a service is to help you get to least privilege. And we talk about the journey to least privilege because, it's really a moving target is what it is. And so Access Analyzer is there at all the various stages of the permissions lifecycle as they evolve over time to help you continue to refine and scope things down. Our mental model for doing this is we think of the permissions lifecycle as there are three phases: set, verify, and refine. Those are pretty self-explanatory. Basically, you create some permissions, then you use Access Analyzer to verify what permissions you have created, make sure that is what you intended, and then finally, if it isn't, you go and refine it, which takes you back to the beginning, and so on and so forth. We have a bunch of different features in Access Analyzer to help you do this. There are 5 of them listed here. I'm going to talk about each of these in a moment, except for policy generation. I'm not going to talk about too much. So I'll give you the TLDR on that, which is you basically create a ** type policy for your application while it's in test. You let it run, you let policy generation analyze the logs, and then it recommends a least privilege policy based on the actions that your application took in test, and then you deploy that to prod. So you don't deploy the ** thing to prod. Please don't do that. You deploy the least privilege policy to prod. But for the rest of these, I'll get into those in just a second. All right. Our secret sauce. One of the very unique things that we do in IAM Access Analyzer is we use a technology called automated reasoning. It's funny, sometimes people ask me like, hey, is that like AI? No. It is the opposite of AI, actually. It's kind of interesting. They both use advanced math, but it's kind of the opposite. So where AI uses probability to predict what will come next, automated reasoning is deterministic. We use mathematical proof to tell you definitively, yes, something is possible, or no, something is not possible. All right? That is literally all I'm going to say about that because it's a super deep topic. So you have 2 options if you want to go deeper. Probably the easier one is the one I'd recommend, which is scan the QR code and go read up on what's there at that link. The second option is go get a PhD in formal logic. So, all right. The features that I'm going to talk about that are part of our Access Analyzer, we have 3 analyzers, 3 different types of analyzers. And so these come in at the verify and refine stage. So you've already deployed permissions. These are like detective controls, okay? So they'll look at all the things that you have already deployed and then give you some findings. They'll tell you, what's going on. The first, and this is the granddaddy of them all, is the External Access Analyzer. This is a free feature, so please, if you do nothing else after this session, go turn this on. Please go turn this on, it's free. And what External Access Analyzer does, you set the scope, either organization level scope or account level scope, and it will tell you, are there any resources inside either the account or the organization that have permitted access outside of that zone of trust, either outside of the account or outside of the organization. And it will produce all those as findings, and you can go through and take some action, either change the scope to remove that or archive the findings, say, yep, that's what I meant. We have the next analyzer that we launched has a little bit different flavor. It's called Unused Access Analyzer. This is the Marie Kondo of analyzers. It helps you get rid of the things that do not bring you joy. What are those? Unused permissions. Permissions that nobody needs that have actually been granted, but that are not used. So this one's pretty simple. You turn it on, you can set the scope, similar to the other one. And what it does, it looks through all the principals in your account or organization, whatever scope you've set, and it will tell you for any given principal, are there any unused permissions? It will also tell you about any unused access keys, unused access keys as well. Or just if you have whole roles or whole users that have not been used in some period of time, it will tell you about those. And the other nice thing that we do is for the unused permissions one, where it's like you have a role and there are just certain permissions in there that have not been used in a long time, we actually will, using automated reasoning, we will recommend, here is the policy that you can replace the permissions with, and that will now be least privilege. Great. All right, and the most recent analyzer type, which we launched at Reinforce this year, so about 6 months ago, is the complement to external access, which is Internal Access Analyzer. So for this particular one, you want to set it on only your most critical AWS resources, like S3 buckets or DynamoDB tables, basically things that only a very, very small number of roles or people should have access to. And what it will do is it will produce a full report of here is everyone inside your organization that has access to that resource and the nature of their access, meaning like what conditions can they access, what are the particular operations they can perform, all of that stuff. Again, only on your most critical resources. This is a very, very computationally expensive thing to do. So it costs money, and it's, there you go. Okay, and finally, so that was on the verify and refine side of the equation. So you've already deployed things, and you want to look at the things that have been deployed, clean them up. What if you want to prevent unintended things from getting into the environment in the first place? So this is at the set phase. For that, we have custom policy checks. Okay, so custom policy checks, the basic idea is they're a set of static APIs that you feed your policies into, and then the APIs, in the case of validate policy, which is a free API, that runs a bunch of AWS best practice checks. It's kind of like a linter for your policies and says, here are all the things that your policy does that it probably shouldn't do. Go clean those up. For the other 3 APIs, the ones that start with check, these are things that are your best practices. So your organizational standards, you would say, hey, I don't think that anybody should have, I don't think this roles should generally have access to S3 delete bucket. That is not something we typically do, so most people shouldn't have access to that. So what we're going to do is we're going to use something like check access not granted. We pass in the policy, and we see, does the policy attempt to grant S3 delete bucket? If it does, that check fails, and then you can take the appropriate action. But if it doesn't, then it passes. Good to go. All right, so there are the options. That's the overview. Wow. I know you don't want to hear me talk anymore. Now we're going to let Mitch jump into some code, some demos, all kinds of things. It's going to be great.
Okay, can you see if the Stream Deck works there in the way we expect it to? Oh, that's awesome. Magic. Excellent. Right, we were trying to figure out if it's best for me to stand up, sit down, hunch over. I'm going to try sitting down to start with. Let's see how that goes. If I start standing up, you'll know I'm not enjoying it, and hopefully. Right. So you've seen and heard from Jeremiah about all of the different analyzers that are available to you. What I'm going to walk you through now is the configuration of those different analyzers. And then Jeremiah, as the engineering leader for the team that builds these things, he's going to provide a bit of color and depth on how these things work underneath the hood. And then we're going to share some best practices for each of the analyzers when it comes to configuration, managing all of the signal that gets generated by these analyzers, and some of the things you can do when it comes to actually responding to and remediating the findings that get generated. We're going to start with External Access Analyzer. And if Jeremiah said before, whilst he was presenting up there was one thing that everyone needs to do when they leave today, if nothing else they remember. Does anyone remember what that was? Beautiful. Good. They're listening. They're listening.
Excellent.
So do that. That's probably lesson number one. So, external analyzer. Okay, hopefully you're all familiar with the AWS Management Console. This is an S3 bucket. It's been labeled external because it made it easier to find it in amongst my 700 S3 buckets that I've got here. We're going to look at this one, and so I'm in an account at the minute that ends with 4447. That's the end of my account. What we can see here in the bucket policy for this S3 bucket is it has a principal in the principal property here that is not my account, and essentially is allowing S3 get object and list bucket on the resources or the objects that are inside of that. That's not really what I want. And that kind of pattern, well, maybe it is. Let me take a step back there for a second. There are some valid use cases for having cross-account access. For the purpose of today's session, that's not what I want. And you can imagine as you create more S3 buckets, if you're in a large organization with many hundreds or thousands of AWS accounts and each of those having their own S3 buckets, you would want to understand and know when and where there are these kinds of configurations that would potentially permit access to your S3 buckets from entities or principals that are not within your zone of trust. So either not within your immediate account or not within your own organization, your AWS organization. So we have an issue here. How do we scale the detection of this kind of thing? And that's really where Access Analyzer's external access comes to play. How do we configure an external access analyzer? Well, this is a code talk. I'm going to paste some command line into here. So it's kind of code, forgive me. But this is how you configure it from a command line perspective. We can also configure this from the management console as well, or using the SDKs, whatever your preferred approach is here. Some really simple configuration options. I want to create a new analyzer, I want to give it a name, and I want to define the type of analyzer. So is it an account scoped or an organizational scoped? The difference being, if it's account scoped, it's going to let me know if anything outside of my current account can access my S3 bucket or my resource. If it's organization scoped, it'll let me know if anything outside of the boundary of my organization can access that resource. And then I define the region that I want to deploy it into. I'm going to hit paste, and I'm going to hit enter. And very quickly, I get a response back with the ARN of the analyzer that's been created. And if we go over to the console here now and hit refresh, hopefully we'll see an analyzer created, which we have. So that worked. That was good. Whilst we wait for a few minutes just for this to start gathering some findings, what I might ask Jeremiah to do now is perhaps provide a little bit of detail on how this works under the covers.
Yeah, absolutely. So basically, the way we generate findings, as you heard, there are kind of two interesting pieces to this. You can't grant cross-account or cross-organization access to a resource without writing a resource policy. So the analyzer starts by pulling the resource policy, and in the case of like S3 buckets where they have some kind of legacy things like access control lists and stuff, we pull all that stuff as well. And then we run our secret sauce automated reasoning, right, to basically deduce, does this thing grant external access, yes or no? And by external, we mean either public, so we have made some potentially big configuration error, and we've granted any untrusted principal access to the bucket, or also grant anybody, just another account access. So the second piece to this is, like Mitch said, we can also create an organization scoped analyzer. And so in order for us to know, is the access that has been granted within or outside the organization, we also have to fetch all of the organization-related metadata, like the organization structure and all the OUs and accounts that are within the organization, so we can determine, is this just granted to another account in the org, or is it granted outside?
Awesome, there you go. And that bought me just enough time then for the analyzers to start gathering some information for me. And as luck would have it, one of the very first findings that got generated through the analyzer, now it's running, and you saw interactively, right? This was live. In a matter of seconds, we started getting this information. The external bucket that I mentioned that I'd misconfigured came up as one of the findings straight away there. So we can see now that it's telling us that there is an external entity. So this is the principal that has access. We can see that the sharing has been done, or the access has been granted via the bucket policy. And we can also see the different types of access that has been granted through that policy that it's looking at there as well. So really quickly, we can start to really figure out, okay, like, do I really want people to access these resources? In this case, it's an S3 bucket. It also can be things like IAM roles as well. And we can see down there that we've got some super special roles that are down here that are accessible via an external AWS account over here, so outside of my current scope. Now, one of the things that over and above just making sure that you enable External Access Analyzer when you leave here today, there are a few other best practices that are worth keeping in mind when it comes to configuring this and managing it on an ongoing basis. I'm going to hit refresh again. You can already see we've got 55 findings that have been generated here now. This is a single account. I don't do much in this particular account, and I'm probably going to burn it when I've finished here today. But in an organization with hundreds or thousands of accounts, you can imagine that all of this can be quite overwhelming. The signal-to-noise ratio gets very, very high. So one of the things that is quite effective at helping you zero in on the things that are most important is to go, well, there are perhaps some things down here that I know I expect to be configured in this way. Maybe some buckets that I do want to be cross-account accessible, or some roles that I have allowed external third parties to assume so they can do things inside of my account. So how do I remove some of that noise so I can zero in on the things that are most important? Well, the way that you can do that, and this is best practice number one, is to create an archive rule. So these archive rules allow you to archive certain types of findings that you don't want to worry about necessarily, because you kind of know that they're supposed to be there. So you can see now I'm going through here. I'm going to create an archive rule. The first thing I did was create the name and make the name correspond to the thing that I'm trying to archive, just because it makes it easier for the next person that comes along and takes my job when I leave to go, okay, that's what that rule does. So now I understand what's happening here. The next thing is I'm going to set some criteria. So I want to archive only if public access is false. I never want to accidentally archive something that is publicly accessible. So I always leave that criteria in there as well. And then the last piece of the criteria is to enter in the name itself of the thing that I want to archive. So and my role is super special role. As you can see, I had a few of those floating around, and they're all part of my administration setup, so I need people to be able to assume them from different accounts. So I've got 61 findings that have been generated or discovered as a result of this archive rule now. So I can just create that archive rule. And what we find then is if I go back to my findings, I get a lot less findings now. So I've dropped down from whatever it was, 70 odd, probably more, down to 31 now. So straight away I can start to zero in on the things that are most important to me as well. I'm going to jump over here. I'm going to put this on the screen because I wanted to have something for you to perhaps photograph on your phones that might be useful for you to take away. But when it comes to things like External Access Analyzer, as we already said, start with your External Access Analyzer. Now, it's free, it doesn't cost anything, and it can give you a whole bunch of useful insights. Create those archive rules to help you really zero in and remove some of the stuff that you don't need to worry too much about. Make sure you're using good naming standards, both for your archive rules, potentially for your analyzers, but also encourage your colleagues who are creating these IAM resources to give their IAM resources friendly names. if I hop back to the findings again, and I look down here at some of these findings, am I on the right? Yeah, I am. If I look down here, have I got anything here? Is there anything in here that perhaps, so look, here's one. This one's called loads of random something. I mean, that doesn't mean anything to me. Like, what does that mean? If my colleagues had given it a name, perhaps this role is a special high-privileged role or something like that, then at least I know what it is and I can go and take some action, or I know who to go and have a conversation with when I'm trying to remediate those roles. Inspect the findings. So if I take a look at that particular one there as well, this more random roles, if I click into this, and let me move my code shell down here a second. So I can see this is the finding that's been generated for this particular role. So the role can be assumed by this external entity. It's the STS assume role permission. The name of that role is this super special role itself. So if I go down here, if I go and find, right, if I take the name of the role and click on this one here, what I can see is that this is the role itself. So this role is able to be assumed by some external principal. It's the external analyzer has told me about it. So should I be worried about that? Well, this role was created on October the 13th. It's never actually been used, and it has some kind of random permissions down here. I don't know if they're necessarily super useful or not, but at least I can see that the role itself hasn't been used, so it gives me a good next step. Let me go and speak to the person that I think owns this role. I can also look here at last access privileges, and I can see that nothing's been used here at all. So there's a good chance that I can go in and I can actually delete this role, but I should go and check with the person that owns it first. But I can delete it to make sure, to remove one extra finding from my external access analyzer, which is great. The other benefit to that is that by inspecting a little deeply, understanding whether that role has been accessed recently and whether it's used any of the permissions that's been granted, I can potentially remove that role and save myself 20 cents when we look at enabling the next analyzer, which is the Unused Access Analyzer, which is where I'm going to talk to right now. By the way, we will take questions, but we'll do this at the end if that's all right, so that we can get through the kind of content first, and also Jeremiah and I will hang around at the end outside if you want to come and speak to us as well. So that's external. Let's look at Unused Access Analyzer now. I've already created an Unused Access Analyzer, but I'm going to quickly just show you the console experience for doing that so you understand what that looks like. So it's a principle-based analyzer, as Jeremiah said. I'm going to give it a name. Again, back to the naming conventions. I get pretty hung up on this, but it's really worth calling these things what they are to make it easy for the next person to come along who picks up your job and understand what you're intending to do there. So I've called it 1 day, Unused Access Analyzer for 1 day. So this is going to look at anything that has permissions or any IAM resources that we're looking at, so principles, that haven't been used in the last 1 day. I've set that to 1 day because, part of the demonstration, we just want to make sure that we can see things and activities. I've given it a name of 1 day. I've set my tracking period to 1 day as well. I've specified the region and the accounts. I've also got the opportunity, if I wanted to exclude certain things from this. So there might be management accounts that I want to exclude from the analyzer if I'm in a big organization. There also might be a series of IAM roles or principles that I expect to have unused permissions. Maybe they're service account related or they're associated with deployment pipelines, that kind of things. And perhaps they don't run every day, or perhaps they run once every 3 months, that kind of thing. So I want to exclude those from my 1 day analyzer. So I can add tag metadata into here to say, exclude these particular ones from you. Through the process, hit create, and then it's going to go ahead and create my unused analyzer for me. Now I'm going to open that up, and whilst I open that up and we wait for the analyzer findings to magically generate, which they have, I'm going to let Jeremiah provide a bit of background on how this analyzer works.
Yeah, so as it turns out, in Access Analyzer, there are 2 very special things that we do. So one is automated reasoning, which I already talked about a little bit. The second one is what powers this analyzer, which is we actually process every single access log. So every IAM access log and every CloudTrail log we process so that we can figure this out. So it's a lot of data, as you might imagine. Also worth noting, there are some last used APIs in the IAM namespace. those APIs also use this index that we build from processing all the log data. So.
Right. So because we're good little demo people, we pre-staged a few things here to try and generate some useful and interesting findings. One of those is a Lambda function that we created that has a whole bunch of excessive permissions and really only uses a handful of those, if any. So I'm going to look at my Lambda function here quickly, and I'm going to look at the permissions here. And we can see this Lambda function has like all the permissions to do all the things. Really, actually, all this Lambda function does is list S3 buckets, so it doesn't need to do all of these things. So what I'm hoping for in a minute is if the demo gods play nicely, we should be able to see a good example of the power of the Unused Access Analyzer. I'm going to copy that name there and take it across. So the finding experience is very similar to what we saw with the external analyzer. So you can see there they have finding IDs. We have all of the different finding types, so whether it's an unused role or unused permissions, or we also have unused access keys, and I'll talk a bit more about that in a second. But what I can do is I can do finding type contains, or actually I'm going to do finding type, I'm just going to do unused permissions. Let's go here. So what we should see, if I scroll down my list here somewhere, do I find it's not there. Let me close that again. Let's go resource contains pop. Okay, so my Lambda function for some reason isn't there today. That's good. We can try this one here. But what we can see is we've got these unused permissions that have identified in this particular role here. So if I go over to here, have a look at the unused permissions underneath this particular role, what I can see is I've already got a list of the permissions that this particular role hasn't used. So it has a series of permissions. It doesn't do any of the things that are listed there. So in addition to it telling me that there are a series of permissions that it isn't using and making some suggestion that I should probably refine those permissions, it also gives me a policy recommendation that I can look at and potentially apply to the role that we associate with this, or this particular role that I brought up on the screen here. So if I look at preview policy, it's looked, as Jeremiah said, at all of the access patterns, all of the logs, and it said, well, this is your existing policy. Here is the recommended policy with all of the actions that you're actually using, or that this principle is actually using. So it's really more of a refined set of permissions. Ideally, it's the least privileged. And as we go through this journey, over time, it will start to understand more about what I am and I'm not using, and I'll continually get that refinement of policy right down to something that really is as least privileged as it needs to be for the thing to do that it needs to do. Now, I talked about creating this at a one-day interval for today. What we generally recommend customers do is start with a fairly large tracking period, so probably 1 year, 365 days. And the reason for that is because there's going to be a lot less things for you to clean up, hopefully, that haven't been used for 365 days or more. Do that. Start there. Look for all those things that haven't been used for that long. It's going to be easier to check things off the list. Once you've done that and you've got rid of everything that hasn't been used for a year or more, wind it down to 270 days, wind it down to 90 days, and take that iterative approach over the remediation process right down till you get to the point where you're at your happy place. Maybe that's 90 days, 30 days often catches people out because there are some processes that use these principles that perhaps don't run every day or week. Maybe it's a 30-day cycle. And you do have to be super careful when you're going through the process of remediating some of these roles because, as I said, there can be processes that use these principles that do not run on as frequently as you're running as the tracking period is defined. So, there could be a pipeline that deploys patches or updates or transforms data that maybe only runs once every 30 days because it does batch ingestion. You don't want to start deleting roles from the account or removing privileges only to find out a month later that some critical data transformation pipeline is broken because you've removed those permissions. So best practices for when you're configuring these, and feel free to take phones out again. Start with that 1 year period, really important. Iterate over that. Consider putting that time series into the name of the analyzer, because when you're looking at all the analyzer findings, you can actually filter by the different names of the analyzer. So you might go, well, I want to look at what hasn't been used for 30 days, what hasn't been used for 70 days, so 90 days. Exclude those accounts that you know are probably going to generate findings. That will save you some money, and obviously remove that the noise from all the useful signals. When it comes to finding types, we generally recommend that customers start by looking at the most challenging areas, or problematic areas, should I say, if that's the right way to say it. Unused access keys is a really good example, right? And I just showed you quickly there how to filter that. So I can look at an unused access key here. This unused access key appears to not have been used in the last day, at least, probably longer. Now, it's not uncommon for engineers to create access keys for demo purposes and testing purposes. But it's good to know they haven't been used, because we can go back to those engineers and say, look, we get you used it for a reason, for part of your project, but let's remove that now because we don't need it to be there anymore. So you can filter these different finding types, really zeroing it down until you get to the point where you've only got what you need. Getting rid of those unused principles, those rules, those unused permissions, roles, should I say, and unused permissions, ultimately, again, saves you money because it won't get analyzed the next time the thing runs. I already mentioned about being careful when it comes to deleting these things, because someone might have a principle that is only used once every month or so. And depending on how you're using this, how you want to use the output and the information, you might consider just running this once every 6 months. I mean, if this is part of an input into an audit cycle you're doing as part of your risk and compliance, this is a compensating control. It helps you understand where your risks are. So if you're doing part of this as a review with auditors or quality assurance people, consider running it every 30 days or every 90 days or every 60 days, or even every month, 6 months. Get the results, provide them to whoever needs them, and then delete the analyzers, because you will get charged for this. It runs every month, so you get charged per resource or per principal per month. So if you're not going to use that information and look at it every day, create it, get the information, delete it, pass it on to someone else. The only thing to keep in mind when you do that is that the archive rules, when you delete the analyzer, get deleted along with it. So if you spent a bunch of time creating some really nice archive rules, you'll have to go back and recreate those. So it's a trade-off, but if cost is something that's really important to you, then you should think about taking that approach as well. And that kind of brings us on to the last analyzer of the analyzer family that Jeremiah talked about here, which is the Internal Access Analyzer. Now, this is one that I've pre-created for you, again, just because we wanted to get some findings that are generated. Now, what we've got on our list of S3 buckets over here, let me just filter these again, is we've got a critical bucket. Now, Jeremiah said, Internal Access Analyzer is really aimed at those critical resources. It's a computationally intensive analyzer, and it has a cost associated with it as well that you should definitely keep in mind. Not only that, it generates a lot of findings because it looks at each resource and it tries to understand every access path that a principal can make to that given resource as well. So in my account, it's not too bad, but in an account where, or maybe in an organization where I've got hundreds or thousands of accounts, there is a lot of information that's generated there. So if you're trying to find that needle in a haystack, it can be quite challenging. So keeping it to your most critical resources is super important. This one, for example, is probably my most critical S3 bucket, where I've got some holiday photos of Jeremiah's here, and I don't want people looking at these. I want to make sure I know who has access to those photos. I'm sure you'd agree with that, right?
Agreed.
Yeah.
I've got to keep people out of that.
Yeah. So with our internal access analyzer, as again, I've already created it, but I'm just going to quickly show you the process so you understand what it looks like here. I've got this, I'm going to call this JD's Photos here. So I'm giving it a name. Again, make sure you make it nice and friendly. And then I can choose the resources that I want to add here. So I can choose all resources from a given account. I can choose specific resources by specifying the Amazon resource name or the ARN for those resources. Or I can choose or upload a CSV that has a list of resources in there as well that will then get analyzed by the internal analyzer. And then I just go and hit create, and hopefully then my analyzer gets created. Now, if I go into here and look at my findings, even for this one single bucket, we can see already that there are a lot of findings in there that have been generated. You can imagine, en masse, this would, for lots of buckets and lots of accounts, this could become a lot harder for us to try and understand and troubleshoot, and when we're looking for specific information in there. Jeremiah, maybe you could share with our wonderful audience a little bit more about how Internal Access Analyzer works.
Yeah, so this one, it's kind of funny because the original External Access Analyzer we launched, I'll just say a long time ago because I don't want to get it wrong, many years ago. But the internal one we just launched like 6 months ago. And so I'm sure some folks were like, huh, like, well, why was it so different? Well, it turned out we had to actually make some new science. Like it was really hard. But what makes it so challenging is one part of it is to actually bring together all of, if you think about it, in order for us to know who inside has access, it's not sufficient to just look at the resource policy. We have to look at every identity policy. We also have to look at all the SCPs and RCPs, right? All the organization control policies, permission boundaries, right? On and on and on. So there's just a tremendous amount of metadata that we have to pull in, combine together, and then run through like a fairly sophisticated scenario analysis, again, using automated reasoning. Yeah, and so it just takes a lot of computation is what it boils down to. Yeah, that's it.
Yeah, if you didn't know, I can't remember if we put it on the slide earlier on, but it does cost $9 per resource per month. So that's why it's something that does require a bit of consideration, and really, it's designed for your most critical resources. So what have we got from our internal analyzer? Well, similar look and feel to what we got from the others, the findings that have been generated. One of the interesting things that you find when you enable this for your resources, for your critical resources, is that you actually see, okay, well, I mean, there's a role here, or an IAM user here, a test user with all of the access. I mean, I don't know what that is, and I'm pretty sure that person doesn't need to see Jeremiah's holiday photos. So if I can click on that and go and inspect a little bit more to see what's actually going on there, we've got this principal, this IAM user called test user. He's got access to all of these things here, but probably doesn't need to see those photos. So again, similar to how I went back into the IAM console earlier on and had a quick look to see if I could find a bit more about this individual, I can see, right, well, here's the user. Well, actually, this user, by virtue of the fact that at some point in the past, I happened to give this user S3 star access, which isn't good practice, but I did because I was probably trying to troubleshoot some issue or help someone move forward with a project. I've inadvertently granted them access to Jeremiah's critical holiday photos now, and that person probably doesn't need access to that. So I could probably go away and go, well, you know what, this actually created in October, hasn't logged into the console before, and I can look at the last accessed API actions as well, and I'm fairly sure it's going to come with no access to S3 whatsoever. So it becomes a potential attack path, a path for data exfiltration or access that I wasn't intending, and I hadn't created it intentionally. It wasn't malicious or nefarious. It was just because I had created a role or user at one point and granted them S3 full access, and now the internal analyzer has helped me understand that there is a way that that particular account, IAM user, if it fell into the wrong hands, would be able to access Jeremiah's holiday photos, and who knows where they would end up. Right.
True that.
Not good. So let me bring up my best practices here again. I think we've kind of harped onto this one a little bit more on the internal analyzer, but keep in mind this is for your most sensitive of resources. There is a lot of noise created for each of those. Sorry, I'll rephrase that. There's a lot of signal created. You need to determine what's noise and what's not. And if you're analyzing an S3 bucket that is accessible from accounts and principals in a large organization, it can become quite overwhelming to really prioritize where do you focus your attention when it comes to cleaning things up. We can import lists of ARNs and use CSVs to help you automatically specify what you want to analyze. And as we talked about, right, this looks pretty intensively at resource policies, principal policies, all the different ways in which a particular resource can be accessed by all the potential principals that can access it as well. So great if you need to do user access reviews. I work with financial services customers in Australia, and a big part of their internal control is user access review. And that can be a very complicated, time-consuming manual process. If we can optimize that even just a little bit by providing this information, mathematically verifiable information, to their auditors and their compliance teams, it takes a whole swath of work off of their plate. So super powerful from that perspective. But it's the cost-benefit trade-off that they need to think about there. So we've talked about the analyzers. These are all in the kind of verify and refine stage. You might be then asking yourself, well, maybe I should be doing things that actually stop these misconfigurations ever getting into the environment in the first place. And I go, yeah, it's probably a really good idea. So just so happens, I'm glad I asked myself that question because we've built something to show you that kind of helps solve that problem a little bit. So what we've built is an example of a pipeline. We're using AWS code pipeline for the purposes of this demo today. This pipeline has been integrated with the Access Analyzer custom policy check capability that Jeremiah brought up on the screen a little bit earlier on. And what we're doing there is we are defining an organizational security standard that says S3 buckets should only be accessible to this account, the account that you're deployed into. If the bucket policy defines any other access path for a principal that is outside of this account, then that's a finding that should block the progress of the pipeline. We should get some feedback on that. And the developer or the engineer that was writing the policy should be able to go and fix that problem. If everything works well, then we should be able to deploy the stack. And this is an infrastructure as code stack. It's in CDK, as you'll see in a moment. But one of the bits of feedback that often I've heard from engineers that are building IAM policies for their applications is, I'm not an IAM expert. I'm an expert in my application. Right? I know what my app's supposed to do. I know the permissions it needs. Well, I know what I want it to do. I don't know exactly how to craft the very nuanced IAM policies that are often required to get the outcome I'm looking for. So if you're going to tell me something's wrong, tell me how to fix it as well. Good. That's fair. That is fair. But it's not scalable for a security engineering team, often of which there are many fewer of those than there are software engineers, to be able to go and work with every single engineer and help figure out how to solve their problems. So what we've done in this scenario is we've actually plugged in Bedrock, because Watson AWS talked during reInvent without a bit of generative AI in there as well. And we're using Bedrock to take the results of the finding and take the policies that we've got and actually provide very prescriptive guidance and recommendation back to the developer in the form of a automatically generated GitHub issue that will get pushed into the project for the developer, so they can then take those actions and go and remediate their policies. So that's how it should work. Let's hop on over to, and this is where we do actually do a little bit of code. Let me find the right Kiro editor, which I've got about 3 open at the minute. It's not that one. It's not that one. It's this one. There we go. Sorry, I just gave myself motion sickness there, flipping between all of those. So here is my CDK project. At the minute, it's set to this account. So it's going to automatically add the account ID of the whichever account I deploy into to the bucket policy here. This is the account that I don't really want to have access. So I'm going to paste that into there. What I've also got as part of our pipeline is this reference policy. So this is my organizational guardrail that says, when you create an S3 bucket, I want to make sure that at a minimum, that this account, so this is my current account, this account, is the only principal or principals within that account that can access my S3 bucket, and these are the only actions that it should have. S3 star against any other, any S3 resource. So if a policy that I attempt to create through my CDK project is anything other than a subset of this policy here, I should get a blocking finding, and it will stop my infrastructure as code template from being deployed. Should. So let's hit save. Let's then let's add in my file. Let's commit here. It's easier probably to type commit. Git commit -m, adding cross accounts, hit. And then I'm going to do git push. This is where it all could come crashing down. It didn't, it worked. Okay, cool. So we've git pushed. What we should see, sorry again for the motion sickness here, is if we go over to our pipeline. So our pipeline, in code pipeline, is kicking into gear. Now this might take a few minutes to run through, but what it's doing is when it gets to this stage over here, I've got 3 different custom policy checks configured. One is check no new access. So this is looking at my policy to determine whether or not I am, to make sure that the policy I'm attempting to create is a subset of that reference policy. And if it's not, it will block and I'll get a failure. Check access not granted. I haven't in this scenario just to keep things simple, but I may have defined a set of IAM actions that I do not want any policy to grant principal access to. And I could list them in there. So I could list, maybe S3 delete bucket, for example. I don't want anyone to do that. So I could add that as a list and it would check those policies and block if it found it. You can also specify resources there. So again, maybe I might take the ARN of Jeremiah's holiday photo bucket, add that to a list of resources and say, if any policy that is being created could potentially grant access to that bucket, just block it, stop it. I want to go and remediate that. And then finally, we've got the good old check no public access, which checks to make sure that the resources I'm creating do not grant public access to the thing that I'm trying to create. If all that goes according to plan and works in the way we expect it to do, then this will just deploy. But because I added that cross-account ID in there, what I'm hoping will happen is that this will fail, and we will then see an error. A GitHub issue automatically generated that then I can go and pass to my developer and go and troubleshoot. So we've got 2 of these through now. And just to play some elevator music and make it a bit more engaging and interesting, I thought I would bring up the logs. So you can see there's a lot going on here. And I'll give you another Easter egg towards the end of the session where you can go and learn a bit more about this and what's actually going on here. But what essentially we're doing is we're synthesizing the CDK project. We're extracting all of the IAM resources out of it, so the principles and the policies. We're then passing that over to a custom Python script that we've created that will then analyze the results that get spat back by the custom policy checks, and then hopefully we should get a failure. So check access not granted and check no public access is good so far, which is what I expected. If I then hop over, I'm just going to jump back into here a second. Let's go down. It should be getting pretty close. There's a lot of noise in here. Cool, it has actually finished, that's good. And it failed. So failed, hopefully because of the fact that we got an issue. So here's the GitHub repository. Hopefully you can all see that. You'll notice we've got 1 issue listed in there at the minute. If I hit refresh, that should turn to 2 issues, which it did. And if I go into here now, so here's the issue that just got created automatically in the pipeline, by the pipeline, should I say. I'll zoom in there a little bit just to show you what this looks like. So this is all powered by Bedrock at the back end. We've essentially passed the reference policy, so our superset of permissions. We've passed the particular statement ID from the policy that Access Analyzer determined to violate what we're asking it for. Both of those have been passed over to Bedrock, along with a fairly prescriptive prompt that guides it to what we want. What we want it to create. So we're essentially building a dynamic prompt where we're giving it a structure, and then we're passing in elements to flesh it out and add more details into it. And we've said, give us some very prescriptive guidance on what exactly it is that we need to do here. So we can see it's given us the problematic statement. So if you've ever run Access Analyzer custom policy checks before against a policy, you may be of the opinion that the feedback you get isn't always super prescriptive. You will usually get the name of the policy that has violated the rules and a statement index ID from 0 to whatever. And if you love grokking IAM policies, then that'll be great. You can just dive in there and figure it out. But if you're normal and you don't, then it can be a bit tricky to try and figure that out. So what we've done is we've found that for you. We've taken that information from the analyzer outputs. We've then grokked the policy statements ourselves. We've taken that particular problematic one out, and we've passed that over to Bedrock as well. So it's given us this. It's outlined the reference policy, and then it's also given us like the specific guidance here. So it said right there, your problematic statement allows access to perform these things, but the reference policy only is configured to permit this particular account. So there's your problem. Here's what you need to go and do to fix that. So step by step. go fix that, walk through that, and remediate that problem. So if I go back here now, I'm going to just take, in fact, what I'll do is I'll go back into here, and I copy and pasted these just to make it a bit easier. If I go back through here and get rid of that, paste that in there, that should work. And I'm going to add git commit and git push. And hopefully the cycle will continue. We will get the pipeline kicking back into gear again in a second, if I find the pipeline. And this time, because now I've used the placeholder value there for the ID of this account, it will auto-populate with the account ending 447, and the analyzer check should pass, the template should get deployed, and we've really, if I was the engineer that was writing that policy, trying to just get my application out there, if you think about the time, the feedback cycle, we've just significantly shortened, because I don't know if you've ever been involved in that tango between the engineer and the security engineer. The security engineer has no context of what you're trying to do. The engineer just knows he's trying to get her thing out there. It's backwards and forwards, and it can take days, sometimes weeks, to really figure out, like, yeah, I'm intending to do this, and here's the reasons why. Now we've been able to give almost instantaneous feedback to the engineer to really help them move much more quickly through the process. So ideally, the analyzers that we went through a little bit earlier on, external, internal, unused access, are really there as additional compensating controls to try and capture anything else that happens to get through the gaps that we weren't expecting. Because we've implemented these preventative or these set controls, a really long way left in that deployment lifecycle to make sure that none of these bad things actually get out there in the first place. So I think that is probably worked as well as I thought it would and hoped. We can probably flip back to the slides now.
Okay. Great. Okay, and yeah, if you are interested in learning more about this, in particular, these like proactive, preventive kinds of checks, there are 2 different things that you'll want to check out here, these 2 QR codes. I'll continue to wait for a second.
Sorry they're so big. Just a lesson learned from a session I did a while back is I put about 5 or 6 of these on one slide once before, and no cameras could focus on any of them. They were all over the place, so we went for big QR codes this time.
Okay, and if you want to go see a good example of this with an actual third-party integration, basically a more full walkthrough of what Mitch just showed using GitHub Actions, there are 2 sessions. So popular that we even got a repeat for that.
Yeah.
Mitch will be there, I won't.
Yeah. Yeah, and we're going to go into a bit more detail of the actual flow and the construction of that dynamic prompt in this session. We're going to show you how we integrate it with GitHub Actions as well. So you can see a little bit more under the covers of how we got the AI-generated analysis and prescriptive guidance back to the engineer. So yeah, if you're in the area on those days, please come along.
And that is it for our content. Thank you all very much.
We would be remiss if we didn't mention that feedback is a gift. So please, if you get a chance to fill out the survey, if you enjoyed the session, let us know. That would be greatly appreciated. A score of 5 is always happy. Yeah, it's a good place. We're happy with that. So yeah, let us know. We'd really appreciate that. Hopefully you found this useful. We've got a few more minutes left, so we're happy to stick around. We can answer some questions either here or outside. Works for us. But thanks. Hopefully you enjoy the rest of the conference.
Yes, thank you all very much.